All right, lesson 2, simplifying rational expressions. So rational expression is any expression which has a variable in the denominator. So you can see all three of these. There's a variable in the denominator. Things like, 3x over 5, that's not a rational expression because there's no variable in the denominator. Okay, you could, write that as 3 over 5x. So the first thing we should do is talk about simplifying fractions just by factoring. And let's factor out some of these fractions. So 32 over 20. 32 is the same as 4 multiplied by 8, and 20 is the same as 4 multiplied by 5. Now, if you recall in past years of math, if you have the same number in the numerator and the denominator, they will simplify to 1, and so you'll just be left with 8 over 5. Same with 40 over 90. 40 is the same as 10 multiplied by 4, and 90 is the same as 10 multiplied by 9. Well, 10 divided by 10 will simplify to 1, so we'll simply be left with 4/9. 12x and 9x. 12 is the same as 3 multiplied by 4 multiplied by x, and 9 is the same as 3 multiplied by 3 multiplied by x. And the 3's will simplify to 1, and the x's will simplify to 1. So you're going to be left with 4/3. Well, the same thing will happen when we get rational expressions. And let's talk about factoring polynomials. So 10x cubed minus 40x, you can factor a 10x. Okay, that means you're dividing each one of these terms by 10x. And so 10x, if you factor that out, you're left with x squared subtract 4. And that's a difference of squares question, so this will become x plus 2, x minus 2. X squared plus 12x minus 45, that will simplify to something like this. And the last one will factor to 4x plus 3, 2x minus 5. That's what we've been doing the last couple days. All right, it's very important that we kind of think about factoring stuff. We're almost getting to where we're going to simplify rational expressions, but we need to talk about non-permissible values. A non-permissible value is anything that will make the denominator equal to 0. Okay? Because you cannot divide by 0. If you divide a number by 0 on your calculator, it will say error. Can't do it. No good. So the non-permissible value of the following. Well, if you put a 0 in for x, that will have become 2 divided by 0, which is no good. So the non-permissible value is x cannot equal 0 in this case. For our next one here, what value could you put in for x to make the denominator 0? Well, if you put a 5 in, that will make the denominator 0. So your non-permissible value, x cannot equal 5. How about the next one here? We've got two things in the denominator. We've got an x, and then we've got this term here, x and positive 3. Well, the first one, x cannot equal 0, because if you put 0 in for x, I guess I could put it in the numerator as well, 0 squared, and then you'd have 0 and positive 3. Well, your denominator is going to be 0 multiplied by 3, which is still 0. And you can't do that. So it doesn't matter which term in the bottom you make 0, they both will. So x cannot equal 0, that's for that one. And x cannot equal negative 3, that's for that one. And you can write these as 0, negative 3. You can just write it in one spot. The next one has 3 variables in the denominator. You've got an x, a y, and a z. So x cannot equal 0, y cannot equal 0, and z cannot equal 0. Here we've got something a little different. Well, let's factor the denominator. So we're going to factor an x and be left with x and negative 6. Well, that will help us identify some non-permissible values. X cannot equal 0 or positive 6. In this next example, we can also factor the denominator. And the denominator will be positive 3 and negative 1, which means x cannot equal negative 3 or positive 1. Here's another example. The bottom, the denominator, looks like a difference of squares. So if you factor the denominator, you'll get positive 5 and negative 5. That means x cannot equal plus or minus 5. In this example, the denominator is already factored. And let me pause for a second. And if you're unsure of what number to put in here or here, what you can do is you can set all three things in the denominator equal to 0. Oops, that's a negative 1. And then solve for x. Well, the first one is already solved for x, so that means x cannot equal 0. In this example, if we subtract 3, we'll get x equaling negative 3, so that means x cannot equal negative 3. And in the last one, you will get x equals 1/2, which means if you put half in there, this term will equal 0. And if this term is 0, 0 multiplied by anything else here will all equal 0. So our three non-permissible values are going to be 0, negative 3, and 1/2. So you could, again, write that in one sort of spot. So 0, negative 3, and 1/2. And you wouldn't need squares around these. Okay. Here comes another example here. Let's factor the denominator. So the numerator, got 3m squared. Let's go back to my purple. 3m squared and subtract 15m. And the denominator is going to factor to 3m minus 1. Okay. So again, if you're unsure of how to get these non-permissible values, take each one of these terms and set them equal to 0 and then solve for m. Okay, so now that we've solved for m, your non-permissible values are that your m cannot equal 1/3 or 5. Like rational numbers, rational expressions can often be simplified by removing a common factor from the numerator and the denominator. So like we saw, I think we had something like 40 over 90. That's the same as 4 multiplied by 10 and 9 multiplied by 10. And then those 10s simplify to 1. So the same thing will occur here. 21 is the same as 7 multiplied by 3 multiplied by y. And 35 is the same as 7 multiplied by 5 multiplied by x. Well, you'll notice that the 7s will simplify to 1, and you'll be left with 3y over 5x. Now, your non-permissible values you need to do on the original expression. So what value could you put in for x to make the denominator 0? And the non-permissible value would be x cannot equal 0. Okay, for this next example, let's figure out our non-permissible values here. So m cannot equal 0 and n cannot equal 0. And 24 and 56 are both divisible by 8. So if you divide both these by 8, this will become 3 and this will become 7. And then let's figure out what's going on with these variables. So this is m with an exponent 1. So if you recall your exponent laws, if you have something like this, that's equivalent to, okay, and one of those m's will simplify. So you subtract exponents. So this will simplify and this will become 2, and then this will simplify and that will become 1. So you're going to be left with 3m squared over 7n. So we've simplified it and we found our non-permissible values. Okay, here's another example. If you factor a x out of the numerator and an x out of the denominator, those x's will simplify. So you'll be left with that is not a square. And your non-permissible values you do on the original expression, so x cannot equal 0. A couple more examples here. 5x plus 10 over 3x and positive 6. So what can you do here? They don't look to be the same, but if you factor a 5 out of the numerator, you'll get x and positive 2, and if you factor 3 out of the denominator, you'll get x and positive 2. Well, looky here. See you later. So you're going to be left with 5/3. And your non-permissible value you have to do on the original expression. So let's take a look at this stage here. If I put a negative 2 in for x, the denominator will equal 0. So our non-permissible value is x cannot equal negative 2. Factor the numerator. And factor the denominator, a difference of squares question. And looky, looky, those will simplify, and you're going to be left with this. Well, your non-permissible values you need to do at this stage before you simplify anything else. So x cannot equal plus or minus 2. Factor your numerator, and factor your denominator. Hello, see you later. So you're left with m over n plus 7, and your non-permissible values, again, do it at this stage before you simplify anything else. So m cannot equal negative 7 or positive 3. Okay. If you factor a 2 out of the numerator, you're left with n and negative 3, and the denominator kind of looks similar, but it's not the same. So if I rearrange the denominator, they're so close. This is positive n, this is negative n, and this is negative 3, and this is positive 3. So what we can do, if you run into the situation where they look similar, but they're not the same signs, if you factor a negative out of the denominator, it suddenly appears that we can simplify this. So this will all simplify to negative 2. And where do we figure out our non-permissible values? It's going to be before we simplify anything. So non-permissible values, n cannot equal 3. Okay, factor your numerator. So first of all, let's take out an x. And in the denominator, you can also factor out an x. We can factor further in the numerator. So I'm factoring this right here. So negative 5 and negative 4. And the denominator will go to x. Positive 5, negative 5. All right, and what can we simplify? Well, the x's and the x and negative 5. So you're left with this term over that term. And our non-permissible values, you would do at this stage, so x cannot equal 0. It cannot equal positive or negative 5. Okay, if you factor the numerator, and you factor the denominator, we run into that same situation where we did just a couple examples ago, where these kind of look the same, but the signs are reversed. So what you need to do is factor the negative and out of one of them, not both of them. So how about we factor a negative out of the numerator? So this becomes x minus 5 and 5 plus x, or x plus 5, whichever order you want to write it in. And the denominator is still 2x plus 1 and x negative 5. So now those will simplify. So you're going to be left with negative over 2x plus 1. And your non-permissible values, you have to do at this stage. So x cannot equal negative half or positive 5.